I'll be distributing the evaluation forms, and it would be really nice if you would submit it within 10-15 minutes, or shall we get collected to me? Don't forget the form that you have to collect the evaluation. Yes. Please fill in this form. This is the last one, or there will be one more tomorrow?
This is the last one. The teaching more or less is done, right? Tomorrow will be more research presentation. So maybe not tutorial tomorrow. Okay, and also try to wrap up the quiz. In a couple of minutes, we'll look at two answers from two groups and discuss those. So, but if you have different answers than those on the board, also let us know. We'll add those to the board. Or you are welcome to just come to the board and add to the others column. Maybe that will go better. That way we won't disturb everyone. Okay. So if your answers are different than what's on the board, just come and add those to the board. Are other answers to be added? Anyone else wants to? All right, so we'll wait about 5 minutes for you to fill out course evaluation, then we'll start the discussion. let's look at the quiz. We'll start with the conceptual one. And the first question is trying to contrast spatial database and spatial data mining. So we are asking, which problem is very difficult in SQL. And we guess people chose wow, A, C, and D. So it's all over the place. So let's actually have a quick vote. Which of the problems are difficult in SQL? First says cluster the data into 3 natural groups, like k-mean kind of thing. So how many of us think it's difficult in SQL? Quite a few of us. Okay.
So it means k-mean, then it is difficult, but then if there's a column with some group, then we can group by that.
So if it is pre-computed for you, okay, interesting. If it is already pre-computed, it's in the database, obviously you can look it up. But typically, when we are asking, give me the natural groups, which means we don't know, right? So typical use case of clustering, if you want to know what people do with it, they always are looking at a new phenomena, so so there is a medical application, New York Times article, right? As you know, over 100 years ago, we actually didn't know that different people have different types of blood, right? So blood transfusion used to be very, very tricky. A lot of people will get sick. And then slowly we clustered people into 4 groups, right? So today we know there are roughly 4 blood groups, right? O, A, B, and AB, right? But now they are trying to classify people based on the gut bacteria. Okay, the type of bacteria that lives inside our digestive system. They are saying it also affects the health. And for example, here if you take antibiotic, kills your bacteria. Sometimes you are prescribed Bicogine or something with good bacteria. People use yogurt. So the question is that are there some natural groups of people based on the gut bacteria? Okay, and this is still being debated, so don't take it as a medical fact. But one technique they are using is this k-means clustering. So there is a group which thinks there are 3 natural groups, and they use k-mean to separate one. Obviously, there's another group which doesn't think so, and they're debating. But that's the one. We don't know if there are natural groups by other things, and that's when we start using clustering. Okay. All right. Now, so as we will argue, so k-mean type of complexity, it is a little bit tricky. So this is not typical use of SQL, but by the way, you should also know that some basic data mining routines have been added to SQL environment, k-means being one of them. Okay, but traditionally in relational algebra, it would be very painful to work with k-mean. It's just that SQL 3 is extensible. You can add other class libraries that people have added it, but that's not a natural use of relational algebra. Okay, B, name the river which flows through at least 6 countries, and no one put that, so which is good. That's easy to answer in SQL. Okay. C, shortest path from New Delhi to Kathmandu, and again SQL, it's not natural, but if you have transitive closure, you can twist and turn it to sort of answer it. It's not actually good. So question 8, any further discussion? Okay, let's go to question 2. And here, the idea was to again impress upon you that independence assumption was a mathematical assumption, it has very little to do with real world, right? So the part A is about, and all of you, the answers are correct. You saw it was a trick question to tell you that independence assumptions is violated all the time, right? But the first question, if you know in probability theory, if 2 things are independent, then the joint probability is a multiplication of the 2, right? And we all realize that doesn't work here. Because again, spatially these names are different places, right? One name is in Middle East, another name is in Far East. Alright, let's go to number 3. And again, there is a consensus, okay, which does not illustrate a hotspot. And it's basically the last one, which is sort of a maxima, minima, or a global outlier. But everything else looks like hotspot. Okay, 3, everyone comfortable? Okay. Let's go to 4. Which one is spatial outlier? And here we have some disagreement. Okay, so how many think B is not a outlier, like a historical place, red, forbidden city in the center of Beijing. How many vote for this, that this is not a spatial outlier? Okay. So the question is, what's the attribute you are looking at, right? If the attribute is the age of the building, Right, then you would see it as an outlier. Basically, the basing, everything has been redone, but they left a few islands, and Forbidden City being one of them. Delhi, I don't know if there are similar examples. Maybe Qutub Minar, right? That's an old structure, but all around Qutub Minar, you have a lot of new things going on. But Red Fort, they left the old Delhi pretty much alone, so you have a lot of old structures together. Same thing in Rome. I think if you go to Colosseum and so on, all around new development, but then you have some old structure there. Okay. So I probably will not pick B. Okay, B is a spatial outlier. Let's see C. Okay. So C, again, you have to ask how common are waterfalls on a river, right? So Mississippi is like, Ganges, little longer, 3,000 miles. How many waterfalls do you think are along Mississippi River? Okay. It does descend, little over 1,000 feet as it goes from Minnesota down to New Orleans. So just to give you a little bit about Minneapolis. Minneapolis was born because of a waterfall in Mississippi River called St. Anthony Falls. Okay. And back then, 150 years ago, you could run hydropower. So this was free power. And they tapped that waterfall to mill wheat. So wheat was grown all around, but it was initially shipped and it was milled elsewhere. But then they got free power, so they would make wheat flour. Okay. And since they had free power, it was cheaper to buy the wheat flour milled in Minneapolis, even in Istanbul. So that's how the city was born. It's called the Mill City. If you go there is a Mill City Museum. And there are roughly 6 waterfalls between St. Paul and Minneapolis, which is about 10 miles. So ships from New Orleans can they can come to St. Paul. But that's where they stop, because then it's painful to go further. But there are not that many waterfalls in the entire Mississippi River, maybe a dozen. Okay. Is that a discontinuity in that linear space? It is, right? It is. So waterfalls would be spatial outliers in the linear space. Okay. So C is also a. So which one should we pick? D. Okay, D is a flat space. Alright, let's go to number 5, and there is some, okay, so co-occurrence pattern. How many vote for A? Okay, a lot of us, okay, good. So these two actually certainly happen together in time, right? Usually lightning flash, so it's more of in time together, but people will call that a slightly different name, right? Coincidence pattern or something we'll call it. Right? Obviously, if you map the lightning all around the world, which is actually happening. NASA just sent up a new satellite for mapping the lightning. Okay. So if you had a global data set and both you could see the light flashes as well as the sound. I don't know if they measured the sound, but if you could see both, will they be localized and interacting in space? So if I look at the map of the places from which you see the lightning, map of the places from where you hear the lightning, okay, and if I fix the time, okay, would you think that these two places will be co-located? Quite likely, right? Obviously, we don't have those data sets, so it's a mute question for a year or two, but those data sets are coming. Okay. Alright, so question 5. Right. So right now, A is probably the best answer, because right now you see it in time, because you don't have global maps available. But in future, all of them would be co-location. Alright, question 6. Again, there is consensus, and I think we are all on the same page. Any other discussion on conceptual quiz? Okay, good. Let's go. Yeah.
It is a spatial co-occurrence.
Right.
In case of A.
In which question?
In question 5.
5, okay.
Read choice A.
Yeah.
A spatial co-occurrence does matter because the start point is the same, so it is only the hearing.
Yeah. Yeah. So if you know the physics, there is a spatial thing. It's just that what I'm saying is today we don't have the maps of where you see lightning and where you hear lightning, right? So most of us experience this in time, right?
But just because of difference of speed that difference will happen.
Right. Yeah, but as I'm telling you that those maps are coming. NASA just launched one for lightning mapping. Lightning again has a lot of ramifications. for societies. That's a different topic. So in 2 years, this question would basically all examples would be co-location. Okay, let's go to the technical quiz. And I apologize that the color did not come out well in the printout, so I will also show you the electronic version. But at least first question, even in black and white, most of you could tell that A had the most smooth kind of feel, right? Whereas B and C actually are showing you remember Professor Punia was mentioning about decision tree? So these are actually satellite imageries that are used to classify land into wetland and non-wetland. So B is an output of, I believe, decision tree, which is very popular. It was very popular in this domain, and it's a nice thing. They're using computer science idea, which is great, right? But what happens in decision tree, again, you have the IID assumption. Each pixel is classified independently of other pixel. Okay, so what you often, when you do that, something will show up here. And what shows up are salt and pepper noise. So you often get a pixel which is water, and every other pixel around it is land. So they often have to do a post processing. If Doctor, if you are still here, you would ask him, how did you deal with salt and pepper noise? And he will say, afterwards we just smoothen things out. Okay, that's typically done. And there is a PhD thesis that was just completed. What that did was to actually change the decision tree algorithm to build in the smoothing inside. Okay, so instead of simply looking at Gini function, I remember he was talking about that entropy function. That's what decision tree uses, which has IID assumption. This function was changed to include autocorrelation. So it was a combination of the two. And then C actually has fewer, not as much salt and pepper as decision tree. Okay? But overall, A is the smooth map. That's what they do with post-processing. So question 1, everyone comfortable? You can all see that A is more smooth. Okay, let's look at B. And it's asking about heterogeneity assumption. And okay, so one vote is for A. Okay, all right. So how many think A is not an example of heterogeneity? Couple of us. Okay, interesting. So A is not about spatial heterogeneity, but basically, if you look at all the cells inside a cancer, so remember, when you try to treat the cancer, there are many different things. But if all the cancer cells are of the same type, okay, then it's very easy for them to get its genetic signature and try to find molecules. It will go and latch on to some part of that cell, like white blood cells. That's how they work. It's a very geometric kind of behavior. So the viruses that our body can deal with effectively, they all have very specific shapes, and your white cell has ways to go and latch on to that molecule and cover it up. Okay? But with cancer, our immune system doesn't work very well, because this is the problem. There is not a unique signature of cancer cell even for a given type of cancer. So that's why our immune system has trouble, as well as when they are developing new immune therapy, they have trouble, because there are so many types and you have to cover that. So it's a heterogeneity example, but not necessarily in space. Okay? So no single treatment can really take care of your cancer. You always have to make a cocktail of many different things and work that works. All right, any other question on discussion on question 2? And again, my point was to tell you that everything I was bringing up, like autocorrelation, heterogeneity, these apply to lots of data set. Okay, just that in space, they are a prime issue, and you ignore it, you really get burned. Okay. All right, let's go to question 3. And this was actually question 3 and 4 are from day 1, but let's go through that. So Vatican and Italy, we all remember that map. Okay, Vatican was surrounded by the Italy. So let's try to think about. So if I look at the exterior, okay, exterior of Italy. Okay, imagine exterior of Italy. So that will be places like France or Mediterranean Sea and so on. And then you look at boundary of Vatican. Do you think boundary of Vatican will overlap with places like Switzerland or Probably not, right? It's surrounded by Italy. So A, the last row, and last row you should see 1-1 in case of Belarus and Lithuania, but not Latvia. So which matrix is that? B. Okay. it's consensus, B is the answer. So at least Poland is the same in all. So I'm going to maybe skip that. We did enough of that before, right? Let's go to the data mining part. So question 5 is about co-location. And it's asking you to compute this participation index. And you are given the neighborhood graph on the right. Okay, that's what will matter. And number 5, okay, there are at least 2 answers, so it's good to discuss. Alright, so let's ignore A for the time. Let's look at B, Pizza Hut and McDonald's. So in the map, how many Pizza Huts we have? 2. So when you see this Pizza Hut, what's the probability of seeing McDonald's? 1. Okay. Now how many McDonald's are there? 3. And when you see a McDonald's, what's the chances of seeing Pizza Hut? 2. So 2 by 3, and I have to take a minimum. So this pair is 2 by 3, right? Okay, let's go to the next, Burger King and McDonald's. So how many Burger King? 1, 2, 3, 4. And if you see a Burger King, what's the probability of seeing McDonald's? 2 out of 4, right? So it's half. Do I need to go further? No, we are done. Okay, so it's B. Okay, so now this is the k-means question, and this is one example where you can fool k-means. So I don't know how many of you traced this, but basically some of the seeds will give you a partitioning that you were not expecting, right? And any of you saw that? This is a symmetric data set. So what is the natural partition? You take the left for one side and right for the other side, right? But if you gave it some seeds, it will actually take the top 4 on one side and bottom 4 on one side, okay? And those seeds, if they were sort of aligned with those 2 lines, so which seed will fool the k-means? Okay, so if you go to B, for example, in case of B, when you do those 2 seeds, then what would happen that every point will fall for 3, 0, right? And then the next iteration, nothing will change. So you will get only one partitioning, right? So one weakness. If you go to C, okay, let's try to see. If you go to C, then see what is happening. This 5, 0, so X is 5. Yeah, that's at the center of the bottom 4, right? And 5 and 3 is the center of the top 4. And no matter of iteration is going to perturb this clustering. You will slice it in a different way, and that's what you were expecting, right? Okay. So remember, it's a greedy descent. It can hit a local minima which is not optimal, right? All those properties of k-means has never been analyzed. It's a real heuristic, but it's real popular. And that's the nature of a lot of machine learning techniques. So if you start thinking carefully about it, you will see some interesting behavior. Okay, so which one actually does get you the proper clustering? A. Okay. So A, you actually see the first seed is closer to the left 4 and the other seed is closer to the right 4. So you will really divide it properly, okay? And so let's see, what did we pick here? A. Okay, what happens with D? It does up and down? I see, okay. Okay, let's go to 7. 7, unfortunately, without the color, it's hard to decipher what is being asked. But this shows you another limitation of k-mean. It tries to do globular things, okay? So let me see if I can project it quickly to show you the colors. So we can switch on this. so here is a collection of points, right? And if I ask for natural clusters with k equal to 3, right? What are you expecting? Let's forget about what k means will do, right? If I showed you this and asked you to make 3 clusters, how many would pick the leftmost as 3 natural groups? Many of us. How many will pick this one? Some of us. How many will pick that one? None of us. Okay, good. Now the question is, which one does k means pick? The second one, because it's based on equal size circles. So if your cluster sizes are quite different, you can get some weird things from k-mean. This is another well-known deficiency. And that's why I keep telling you, I'm not saying reject k-mean. All I'm saying is look at what it's doing. Don't take it blindly. Okay, that's all.
Sir,
Yeah.
like what we studied of k-mean, there is also property where in case the cluster size goes beyond the threshold,
Right.
it will break it into 2.
Okay. So then you have to know the size somehow. Yeah.
So in that case, in the second one, if that because if that cluster size is going beyond,
Right.
if it goes beyond, sometimes will break it.
So that's the algorithm. Algorithm you can do whatever you please. But the question is, your end user, when I look at this, what were I expecting? Okay? Because ultimately that's the truth. Right? I mean, would you break it up like that? Sometimes you might, if you're worried about capacity constraint, you got to, these are all the population people, right? And I'm putting the shelter, but each shelter has same capacity. Then I need to break it up because this shelter will be overwhelmed, okay? And in that case, maybe what's happening here may be sensible, right? But in some other cases, like I'm talking about, gut bacteria, and I'm saying, this is the, some 2-dimension in which bacteria live, and I'm asking you for 3 natural groups of people, then maybe this is what makes sense. Okay. So again, I'm not trying to reject k-means altogether. All I'm telling you, look at what it's doing. Don't just do it blindly. I ran the software and I'm done. Okay, which is often the case with the data mining machine learning literature. All right. So 7 we have set. Move forward. Okay. So let's go to the number 8. Which statements are false? Number 8, so now I gave, remember this declustered data, okay, see what happens. So how many vote for A? Okay, so we're looking for things which are false, okay. So will SAT scan find anything here? No, there are no dense areas, okay, so even the likelihood ratio threshold will fail, okay. P-value will suddenly tell you there is nothing out there, okay. How about K-means? Will it find 2 clusters? Yes. Can you tell what clusters would be?
Depends on the initial.
Depends on your seed, right? It could cut it like this, it could cut it like that, it could cut it like that, it could cut it like, you don't know what you will get. Okay, so look at it, that's all I'm saying. Okay? K equal to 3, will you get 3 clusters?
Yes.
Yes, okay. SAT scan may output a circle which has high likelihood threshold, but it will fail the p-value. How many think it's true? Okay. It's possible because k-mean is actually set to give you always one circle, which is the highest likelihood. But my case is even that circle may not make the cut here. You have to have at least 2 points come together. Okay, so this case SAT scan probably will tell you there is nothing out there right away. It won't even go to p-value. Okay? But in complete spatial randomness, occasionally you have a pair of points which are close to each other, and they will pass the likelihood threshold test, but fail the p-value. Good. Any other questions on 8? Okay, let's go to 9. Okay, so this map is actually a very discussed map in US election of year 2000. And that election, you remember, was somewhat like the current election with Al Gore and George Bush Jr. And it came very close election, went to Supreme Court and all. And Miami-Dade County, people were worried about it. So anyway, which one is a spatial outlier here? Okay, how many think A? Okay, which is, so A, how many think is spatial outlier? Quite a few. Good. All the neighbors are one color, this is other. Okay, B, probably not, only one neighbor is different. C, okay, C, most neighbors are different except one, right? So probably it's likely, spatial outlier score will be pretty high, okay? Not as high as A, but it will be pretty high, okay? And C and D both would have relatively high score, okay? So A for sure, and quite likely C and D, okay? Okay, so this is the map, the first question you are seeing, okay, ground truth, model A's prediction, model B's prediction, and you kind of see these little pixels, just little bit of green surrounded by red, or you kind of see these little pixel red surrounded by green. Those are called salt and pepper, okay, and then you do a post-processing today to make it smooth. And that's what IID assumption does. So both of them have some amount of salt and pepper. But basically we are asking which one has most salt and pepper, B or C? How many vote for B? How many vote for C? Fewer, okay. So this is decision tree and that's spatial decision tree, okay. That's from recent thesis. Okay, go to 11. Okay. So, oh wow, I don't know if you can read these numbers, so I will read it aloud, okay? So the leftmost, the p-value is 0.7. Second one is 1, okay, third one 0.001 and fourth one?
001.
Okay, p-value 001. So it's basically asking you to interpret p-values, right? That's all. And as we told you, acceptable is somewhere around 0.05 or if you're more rigorous, 0.001. So which, okay, A, how many think is this a statistically significant hotspot? No one, okay, B, C, a lot more, okay. So if you have to pick, only, so C, how about D? How many think those? Okay, good. So it depends on your level, but either you pick 0.05 or 0.001, these will make it, these will not. So C and D is the third one. Alright, any closing questions on this topic? Alright, good. So I don't want to stand between you and lunch anymore, so let's wrap up. And tomorrow we are going to some assorted research topics, so there will be one evacuation route planning. And if, that probably is of interest to many of you because of the societal connection. And then I will introduce one other topic which is a very new burning topic called nexus of food, energy, water. And it's a very live discussion, so hopefully we'll try to connect to your interest. But it's a very serious problem around the world, a very high priority societal issue, and data science is essential. So basically we'll make an argument data science has to play a role and talk about some new research challenges in that context.